Okay, in this example, we got a couple different ones embedded in this, but we are going to be using our random functions to kind of predict what's going to happen without knowing what's going on. So we're going to look at Walton Bookstore must decide how many of the next year's nature calendars to order. Each calendar costs the bookstore $7.50, and they sell them for $10. After January 1st, all unsold calendars can be returned to the publisher for a $2.50 refund per calendar. Walton believes the number of calendars it can sell by January 1st follows some probability distribution with a mean of 200. So Walton believes that, hey, well, if the mean's 200, let's order the average demand and everything will be fine. So the question is that a good decision? Now this gets into where we don't know what's going to happen because we have no idea what the actual demand is going to be. It could be 50 calendars, it could be 500 calendars. So what we're going to have to do is we will have to figure out, we're going to have to do some guesstimating. We're going to have to do some simulation. And so over the course of this problem, we're going to do a couple of different distributions. We will do a discrete distribution, we will do a uniform distribution, and then we will also do a normal distribution. So let's get ready, and we're going to start right here with our general discrete distribution. And so a lot of these sheets are going to look similar. At the top, we're going to have the cost data, the unit cost, unit price, and unit refund. We will have our decision variable, which in this case is our order quantity. How much do we want to order? And so for this first one, we have a discrete distribution. So basically the demand, he has figured out that there is a 10% probability that will be 100 calendars per year, a 25% chance that it will be 150, a 30% chance that it will be 200, 25% chance it will be 250, and a 10% chance that it will be 300. So the average demand is what he expects from the statistics. And as we know, as we remember from our statistical classes, that if I take the demands and I sum product it with the probability, that will give me the expected value of that distribution. So let's do that right now. So sum product of our demands and our probability. So it's taking each probability, multiplying it by its demand, adding it all together. And so that's going to tell us that we have an average demand of 200, which is what we were told in the problem. So we don't know what things are going to be. So what are we going to do? We are going to do some random simulation. So as you look here, we have this green column that says random. That's where we're going to put our random number generator in. And you can see we're going to simulate this 1,000 times. So we're going to go, okay, well, this is what this run is. This is what this run is. Then we're going to take the average of all of our simulations, take the standard deviation of our simulations, and basically try to figure out, based on probability, what's the best decision to make. All right, so what are we going to do? Well, first of all, we're going to use simulation. And so in simulation, we're going to use a function. We're going to use our rand function. So rand is one of the few functions where you don't put anything in the parentheses. It's just open parentheses, close parentheses. What does rand do? Well, that generates a continuous variable between 0 and 1. The continuous part is what's important because that means that it's going to give you any fractional value between 0 and 1. If it was discrete, it would only give you the integers. So let's just throw that in right now so we've got something to work with. So rand, open, close, and there we go. So we've generated a random number. We don't need to see all that. Let's just keep it to, we'll keep it to 3 data points. Okay, and so that is the number that we are going to use to calculate everything out. Okay, so if we're looking at that, so if I have my random variable, And so this is the percentage chance. Basically, it's the probability. 64%. So if I go and I look in my table here, that would be 10, add 25 to it. So that's 35. Adding 30 to it makes it 65. So that would be 200 calendars. Obviously, we don't want to do that every single time because we've got 1,000 of these. We want it to calculate it out on its own. But Excel can't really go through and do that mental math that I just did. So what we need to do is we're going to come over here and we're going to make a cumulative probability column. So basically, the calendars start at 0% probability. I want you to notice something. But that was 65 before. Now it's 0.239. What's going on? Whenever you have any of the random number generators in Excel, every time that it would force something to execute, which is basically every time you hit the answer button, it's going to generate a new random number. That's going to happen. That's fine. That's what it's meant to do. That's also we're doing 1,000 simulations, is to kind of even this stuff out. Okay, so cumulative probability for demand starts at 0, and it's going to go to 10%. So what I'm going to do over here is I'm just going to bring my 10% over there. So when I get to 10%, it switches over to 150. And so that's going to go on for 25%. So what I'll do here is I'm going to equal my first probability where it starts to my ending probability. So that's going to go from 10 to 35. Now at this point, I can drag them down because the next one's going to be 35 plus the 30, which should bring me to 65, and then to 90. And I'm going to take it one more just to make sure it goes to 100, because I want everything to go up to 100%. Why did I do this? I did this because I want to be able to use this now as a lookup table, where I can use my probability as my lookup value and being able to return values based on that. So actually, I will give this one a name. So we'll call this discrete underscore. We need the underscore because we can't put spaces in there, and so we'll call that discrete demand. Because I am going to be using this and dragging it down, so I want to be able to hold that one there. And it'll be different for the other ones because we can call it uniform demand and normal demand. Okay, so if I come out to 0.048, which is 5%, a little less than 5%, how do I figure out what my demand is? Well, I'm going to pull my demand off this table using this probability. So we're going to use the VLOOKUP command. And VLOOKUP is a great command. It looks up a value in a table and then returns something from the table. Now, I grabbed all 3 of these columns in here. I don't actually need this one here, but it doesn't matter. It's just there. The important thing for a VLOOKUP table, it's always going to be the first column, because that's where the lookup's going to start. And so our lookup value is going to be this random number. And then the table array is going to be this table that I did. And see, I highlighted it. Discrete demand, it will not index. And then it's the column index number. So if I put 1, it's going to return that first column there. And let's say I just end this and leave it in there. So you can see it came up random. It's looking up the 0.304, and why is it giving me 0.1 instead of 0.35? Because 0.35 is closer. What's going on is it's going to grab, it's like Price is Right. It's going to grab the lowest, it's going to grab the closest without going over. And so since we did not get over that 0.35 hump, we're locked at 0.31. Now, there was another indicator in there. If we go to put the column in, we get true and false. True means it's going to give you an approximate match, which is what it just did for me there. False means it needs to have an exact match. So if I put a 0 in here now and run it, you're going to see I get a not applicable, an NA. That means that there's not an exact 7.35 anywhere in here. So a lot of, especially when we're doing random numbers, we're going to want to be using true. And it's true by default, so you don't have to actually put that in. And we do want to grab column 2 because I want it returning the demand. Okay, there we go. 0.443 gets to 3.5, doesn't get to 6.5, so it's going to spit out a demand of 200. Would we ever use the false? Yes, we would. There are cases where you know that you're going to be generating data and you're guaranteed it's going to be one of the ones on the list. That's where you would use false to kind of force it to where it's going. But in our random number generation here, that's not going to work out. Okay, let's finish out this top part here. So revenue, we're going to order 10 calendars in here just because I want a placeholder number. So what's my revenue going to be? Well, revenue is simply going to be how many I order. Actually, no, that is not true because we're not guaranteed to sell what we're going to order. Our revenue is going to be based on, let me give this another number. Let's say this is 300. So let's say that I order 300 of them, but there's only demand of 250. Well, obviously I can only sell 250 because nobody wants any more than that. On the other side, if I only order 50 and people want 200, well, I can only order 50 because that's all I have. So this is where we get into the revenue. We need the minimum of those two values. So I'm going to do the minimum of either demand or order quantity. And so if I do that now, demand was 300, but I can only sell 50, so that works out. So let's go back in here and let's make a change. We want that B9 never to change, so we'll put our dollar signs in there. But then that's just the number of calendars, and then we're going to multiply it by what we're going to get out of it. So we're going to get $10 for every one that we sell. That's our revenue. So we look at it here. I buy 50 of them. Demand's 250. So I'm going to make $500 in revenue. And let's say I put 400 in. Well, I can only get 200. So its revenue's 2,000. I have another 200 calendars that I have to send back now. And we'll take care of that when we get here to the refund part. But with a little bit of time left, let's just go to our cost. Now, our cost doesn't matter what the demand is. It's purely going to be based on the order quantity. And I'm going to put my dollar signs in because I don't want that order quantity to change because it's going to be the same for all. And then I'm going to multiply that by the cost. And once again, I don't want the cost to change, so I will lock that one in too. So the cost is going to be the same for all of our simulations because we're ordering the same amount of calendars. So ordering 400 calendars, my unit price is my cost is $750. That means it's going to cost me $3,000 to buy the calendars. I've only got 200 people demanding it, so I'm only going to make $2,000. That's going to be a problem. But that's why we're doing the simulation, to figure that out. So we're going to stop right here. In the next video, we will go and we will figure out the refunds and do all the probability calculations.